Here's my audience for my speech, my mom and my two brothers. According to Whitman and Johnson in their textbooks, Refrigeration and Air Conditioning Technology, refrigeration relates to the cooling of air to provide the cooler temperatures to preserve food, make ice, cool beverages, or other cooling applications. Before modern refrigeration, food was kept cool with ice transported from the mountains. According to Encyclopedia Online, the first known artificial refrigeration was demonstrated by William Cullen in 1748. But it wasn't until 1805 that an American inventor, Oliver Evans, designed the first machine that used vapor to cool an area. Commercial refrigeration was believed to have started with an American businessman, Alexander Twining, in 1856. Maybe this is where the term twinning, called where you have two indoor units stacked by each other, came from. I don't have any source stating that, but when I came across this name in my research of the history of refrigeration, this came to mind. And I thought they might be related. The modern refrigeration process has changed a lot since the days of Alexander Twining, as Marshall Bryan and Sarah Elliott point out in their How Stuff Works article. The four main components of the modern refrigeration cycles are the compressor, the condenser, the metering device, and the evaporator. The compressor is a vapor pump that pumps refrigerant from one pressure level to a high pressure level. The compressor is like the heart of the system. It pumps the refrigerant throughout the system. It reduces the pressure on the low side and increases pressure on the high side, making the refrigerant flow. The compressor can only take vapor into it. If it gets liquid back into it, it will cause liquid slugging and mess up. The condenser transfers heat from the system by condensing refrigerant or cooling the vapor to a liquid. The condenser is your outdoor unit. It is going to reject the heat from the system, allowing the vapor from the compressor to condense. The vapor coming into the condenser is a high pressure, high temperature vapor, and it leaves the condenser a high temperature, high pressure liquid. The metering device is a valve or a small tube that meters the liquid refrigerant into the evaporator. When the refrigerant goes through the metering device, it enters a high temperature, high pressure, 100% liquid, and in the metering device it flashes off to about a 70% liquid, 30% vapor mix. Then the evaporator is a component in the refrigeration system that absorbs heat into the system and evaporates the liquid refrigerant. After the refrigerant leaves the metering device, it is at a low temperature, low pressure, 70%, 30% vapor mix entering the evaporator. Then the evaporator absorbs heat and evaporates the liquid off, making it 100% vapor. Then at 100% vapor and a low temperature, low pressure, it is safe to go back to the compressor and complete the cycle all over again. In conclusion, refrigeration has come a long way from being brought from the mountains and used to keep food cool to the early attempts at mechanical refrigeration, all the way to the complex systems running in all of your homes today. The four main components of a modern refrigeration cycle are the compressor, which is the heart of the system pumping the refrigerant, the condenser, which is the outdoor unit condensing the vapor refrigerant to a liquid, and the metering device, which converts the refrigerant to about a 70%, 30% vapor mix. And finally, the evaporator, which evaporates the liquid off to 100% vapor and sends it back to the compressor to start the cycle all over again. I hope I have simplified the refrigeration process enough so that my audience has a basic idea of how the system cooling their homes and keeping their food from spoiling work. Thank you.